A sudden concussive boom ripped through the quiet afternoon across northeast Ohio, rattling homes and sparking immediate alarm. From Cleveland to Akron, residents reported a sound so profound it felt like an explosion, leaving a trail of questions in its wake. This wasn't a distant thunderclap or a construction blast. This was something far more widespread, far more mysterious, and for a tense few hours, entirely unexplained. The sheer force of the event sent shivers through communities, prompting a flurry of calls to emergency services and a collective gaze towards the sky. What force could unleash such an auditory shockwave across such a vast area? The answer, as it unfolded, pointed not to an earthly disturbance, but to a celestial visitor, a silent traveler from the cosmos making a dramatic, albeit brief, appearance over our atmosphere. The stakes were immediate, understanding the source of this profound disruption and reassuring a region left shaken by an invisible force. This event serves as a potent reminder of the dynamic, often unpredictable, interactions between our planet and the vast expanse of space, bringing the cosmic drama right to our doorstep. The initial confusion quickly gave way to a collective effort to understand, as local news channels and social media platforms became hubs for shared experiences and speculation. The sheer volume of reports underscored the magnitude of the event, confirming it was not an isolated incident but a regional phenomenon that demanded an explanation. This was more than just a loud noise. It was a moment that momentarily paused daily life, forcing everyone to look up and wonder. As the initial shock subsided, the search for answers intensified. Eyewitness accounts flooded in, painting a picture of a widespread, powerful sonic event. Many described their houses shaking, windows rattling, and a deep, resonant rumble that seemed to come from everywhere and nowhere at once. The National Weather Service office in Cleveland quickly became a focal point, fielding inquiries and analyzing atmospheric data. Their initial assessment ruled out seismic activity, confirming it wasn't an earthquake. This immediately narrowed the possibilities, pushing the investigation towards atmospheric or extraterrestrial origins. The absence of any reported ground impact or visible smoke plumes further deepened the mystery, eliminating conventional explosions or industrial accidents from the list of likely culprits. The tension mounted as theories circulated, ranging from military aircraft breaking the sound barrier to more speculative ideas. What was clear was that a significant amount of energy had been released into the atmosphere, creating a pressure wave that propagated across dozens of miles. The NWS, leveraging its sophisticated monitoring equipment, began to piece together the puzzle, looking for anomalies in radar and satellite data that could explain the widespread sonic disturbance. This methodical approach was crucial in moving beyond speculation and towards a verifiable scientific explanation, providing the first concrete clues to the true nature of the event that had startled an entire metropolitan area. The public waited, eager for clarity amidst the lingering echoes of the boom. The scientific explanation for Cleveland's mysterious boom soon emerged, pointing to a phenomenon far beyond human control. A meteor, not a meteor that struck the ground, but one that disintegrated high in Earth's atmosphere. When a meteoroid, a piece of space rock, enters our planet's atmosphere at incredibly high speeds, it generates immense friction. This friction causes the meteoroid to heat up rapidly, often leading to its fragmentation or complete vaporization. The rapid deceleration and breakup create a powerful shockwave, essentially a natural sonic boom. As the object travels faster than the speed of sound, the atmospheric entry event can release energy equivalent to several tons of TNT, producing an audible blast that can be heard over vast distances, even if the object itself never reaches the surface. The National Weather Service confirmed that their geostationary lightning mapper, or GLM, detected a flash over Lake Erie, consistent with a meteor's atmospheric entry. This crucial piece of data provided the definitive evidence needed to identify the source of the widespread sound. The GLM, typically used to detect lightning, is also sensitive enough to pick up the bright flashes associated with meteors burning up in the upper atmosphere. This confirmation shifted the narrative from an unknown threat to a fascinating celestial occurrence, offering a tangible explanation for the profound auditory experience felt across the region. It underscored the constant, albeit often unseen, cosmic activity impacting our planet. The confirmation of a meteor as the source brought both relief and a deeper understanding to the residents of Northeast Ohio. While the initial boom was startling, knowing its origin as a natural, high-altitude event alleviated fears of a ground-level explosion or other immediate dangers. The meteor's trajectory and fragmentation occurred well above the Earth's surface, meaning there was no impact crater or debris field to be found on land. This is a common outcome for smaller meteors which burn up completely or break into tiny harmless fragments before reaching the ground. The widespread nature of the sonic boom was a direct result of the meteor's high altitude and the efficient propagation of sound waves through the atmosphere. The event served as a powerful real-world lesson in atmospheric physics and astronomy, demonstrating how even relatively small objects from space can create significant, observable effects on Earth. Experts explained that while such events are not daily occurrences, they are also not exceedingly rare, with countless small meteors entering Earth's atmosphere every year. Most go unnoticed, but those with the right size, speed, and entry angle can produce these dramatic sonic displays. The Cleveland event became a case study, illustrating the protective role of our atmosphere in shielding us from constant cosmic bombardment, turning potential impacts into spectacular, albeit noisy, light shows. It was a reminder of the dynamic, ever-changing environment of our solar system and our place within it. The Cleveland meteor event ultimately provided a compelling narrative of mystery, scientific investigation, and resolution. What began as a moment of widespread confusion and concern transformed into a clear, verifiable understanding of a natural phenomenon. The rapid response from local authorities and scientific agencies, particularly the National Weather Service, was instrumental in quickly identifying the meteor as the cause, effectively dispelling rumors and providing accurate information to the public. This incident highlights the importance of robust monitoring systems, like the geostationary lightning mapper, which can detect and help explain unexpected atmospheric events. It also underscores the value of public engagement in reporting unusual occurrences, as countless eyewitness accounts provided crucial context for investigators. The loud boom over Northeast Ohio was more than just a fleeting sound. It was a powerful, albeit brief, connection to the cosmos, reminding us of the constant interplay between our planet and the vast universe. It offered a unique opportunity for public education on meteors, sonic booms, and the protective shield of Earth's atmosphere. As we continue to explore space, events like these serve as natural laboratories, helping us better understand the objects that share our solar system and the dynamic processes that shape our world. Stay curious, stay informed, and remember that sometimes the most profound events are those that come from above. What other cosmic wonders might be silently passing us by, waiting for the perfect atmospheric conditions to announce their presence?